Namaste, welcome to my 10th tutorial. I'm Mohangiri. In this tutorial, I will be talking about Monte Carlo integration and the method of finding value of pi by using Monte Carlo integration. In this method, we will consider a unit circle, circle of unit radius. Similarly, that unit circle inside a unit square. So within this unit square, this unit circle lies, and we will throw a dart from far and in such a way that the dart would be inside the unit square at any cost. Alright, so okay, so we will throw a lot of darts randomly. Previously in my previous video I talked about the few introduction of random numbers. Random numbers are those numbers which are not repeated, or which gives a random walk or any numbers within the given interval. So yes, just like random numbers, we will throw a lot of darts inside the unit square, and some darts will lie right inside the unit circle, but few of the dart will remain right outside the unit circle but right inside the unit square. So during this case, okay, so we can consider okay, this whole unit square as area of it as r square, or simply 1, and similarly for this unit circle area can be considered as pi. Alright, but so while approximating it, this gives a quarter of the unit circle. Alright, so for that, because of that, okay, pi can be obtained by this formula, because ratio of area of the circle and area of the unit square is pi by 4. So while reverting this relation, we can get this: pi equals 4 times actually area of the circle over area of the unit square. But that area can be replaced by these random numbers of darts thrown right inside the circle and right outside the circle. So outside the circle but inside the unit square. So because of that, this is our formula. So pi equals 4 times number of points inside the circle over total number of points on or inside the square, means inside this as well as this. So okay, in denominator, this is the number of points inside the square, means total number of darts thrown, and this is the number of darts thrown right inside the circle. So how can we check the number of darts they are inside the circle? For that, we can check by using this formula. So in two-dimensional axis, if x square and y square and its addition is less than 1, then that means radius. So x square plus y square is less than 1, that means those points will lie right inside the circle, and if equal to 1 or greater than 1, then that will lie right outside the circle but inside the square. So okay, out of total number of darts thrown, we can check the number of darts inside the circle by using this formula. Okay, so that we simply can calculate value of pi. Pi equals 4 times number of darts thrown inside the circle over number of darts, total number of darts. Alright, so to do this, we will go to Fortran by opening Genie as my document editor. Okay, so yes, let me save it as Fortran or .df90. Okay, I will name it as pi emc dot f 90. Okay, so this is the document editor where I want to create Fortran file. For that, you know the format of the program by using Monte Carlo simulation. Okay, and this is the format of the program, you know. So before discussing how to find the value of pi, I will talk about random numbers. How random numbers can be generated, a little bit different than in my previous video, right? So for that, yes, you know, implicit known is always required. Instead of real, I will use double precision because this gives more precise value than that of real parameters. So I use double precision here. Integer is of course integer, there is no problem on that. Okay, so first of all, how many darts we want to throw? I think it is better to give input as the total number of darts instead of fixing the value of darts. Alright, so for that, print, please insert the number of darts that you want to throw. Okay, so read this as yan. Alright, so this yan is nothing but integer, define it as integer. So this is the number of darts that I want to throw or you want to throw. Alright, so first of all, let us find how random number works. First of all, let me define double precision R here as my number of arrays 2. So I am writing this R2 for random numbers, and for finding out random numbers, nth random numbers, I need to use do loop as I am doing from earlier. Okay, so I runs from 1 to n, and this is the format of the do loop. Okay, so to find random numbers, I will use call subroutine instead of using rand. Okay, so as I was doing in my earlier video, so call random underscore number. So this is the format of calling random numbers. This is the intrinsic subroutine of the Fortran, and we can call at any time by defining this R as here, and this is the number of dimensions in the array. Alright, so random number. Now let us check whether this random number works or not. To check it, you know, the format is of course print. I want to have two rows of random numbers, that's why I am using R1 and R2. Alright, and this is the dimension. Okay, so let us check whether this works. I have used R over here, yan over here. I should define I as our integer. So this is the format of generating random numbers. Let us check whether this works. Okay, so please insert the number of darts that you want to throw. Okay, I want to throw first of all 10 darts. Yes, so these are the two sets of random numbers, non-repeating, even though they are pseudo-random numbers, but not true random numbers, because these are also created in a certain format. Okay, let me check few more times. Let me throw 1 lakh darts. Then yes, this is how it creates random numbers between 0 and 1. Alright, so this is also another way of creating random numbers in between 0 and 1 in various formats. Alright, so this is how we can generate random numbers. Now as I shared earlier, this is the formula of pi, and and okay, the number should satisfy this condition. All right, so in our code what we do is yes, after generating random number, what we do is, first of all, we define norm here. Norm equals r1. I will define r1 as my x-axis, so r1 square plus r2, yes, squared. Yes, so this is the norm. Norm means exactly this, x square plus y square, means r1 square plus r2 square. This should be less than 1, right? So to check that, first of all we define norm, but this norm should be a real parameter. To have more precise value, I am using double precision norm. Alright, so this is norm, and after getting norm we have to satisfy this condition. Sure. Okay, so to satisfy that condition, after satisfying that condition, if any value of r1 and r2 satisfies its norm as less than 1, then that point lies right inside this circle. So that point should be counted as 1. Alright, so after satisfying this relation each time, the number of dots that is belonging right inside the circle should be increased by 1. So to do that, to count iterations, I will define yum equals 0 first, because without doing anything yum will be 0. Right, so after okay, if satisfying means yes, we need to satisfy this condition, right? If num is less than dot lt dot space 1. Actually, to be more precise, we won't write only 1. For our double precision value we will use 00d0. Alright, so this gives more precise. Actually, don't be confused, this is 1. These things are added to get more precise answer, right? So if num is less than 1, less than or equal to 1, then what we do is, okay, first yum was 1, 0, that means there were no dot right inside the circle. After satisfying r1 and r2 as this norm is less than 1, then we should count that point as our 1 point inside the dot. So for that we will define yum equals yum plus 1. This simply will be increased as soon as the this condition will be satisfied for all value of I. Okay, so this is how yum can be calculated. Alright, so yum means number of dots that are belonging or satisfying this condition, means belonging inside the circle. So in denominator we have to find the total number of points right inside the circle, means total number of dots thrown, because every dots thrown is right inside the circle. Okay, because circle is unit circle and random number, this computer this program is creating random number between 0 to 1, means every numbers are right inside the unit square. Alright, so this is yum. Now let us define pi. So as I showed in this formula, pi equals 4 times number of point inside the circle, means yum, over total number of point, means of course I. Alright, so pi equals 4 times, actually 4 is also can also be written as this to get more precise value. Actually this is 4 times number of dots inside the circle divided by total number of dots. Alright, this is our formula of pi, right? Similar as this, 4 times yum divided by I. Okay, so yes, this is pi. I should define this pi as real parameter as double precision to get more precise value. in place of real parameter. Okay. Yes, this is by using Monte Carlo simulation. Alright, so let us print the value of pi in our answer. Alright, so yes, this is pi. Yes, why not? We compare real value of pi. You know, real value of pi is 4 times what? Arc 10 means 8, 10, 1, right? So tan inverse 1. And to be more precise, it is also written as this. Okay, so yes, this is the real value of pi. Okay, let us compare only pi and pi using Monte Carlo and real value of pi. Okay, so we can simply check it. If we want to get only one answer, then this undo should be here, and yes, print should be right outside the do loop. But we want to see the pattern. Okay, also we can find errors also. So for that, what we can do is we can define error equals pi first of all absolute value of pi using Monte Carlo minus this value. Let us copy this and paste it. This is the real value of pi. Alright, don't be confused with it. This is the 4 into arc 10 1 means this is pi by 4 cancel, and it will give a real pi. Alright, so pi minus real value of pi divided by real value of pi. So this gives nothing but the percentage error. So to get percentage error, we should multiply here by 100. Yes, absolutely. So this is how we can get error. We can print error in our display board, and we need to define that error as double precision, and this is actually relative error or percentage error. Okay, let us write end if. I have used if here, but I have not ended this statement, so end if should be included here. Yes, yum is not defined. Actually yum is the integer. Okay, number of darts thrown inside the circle is integer. Now everything should be fine. Yes, so it is successfully finished. Let's check it whether it works. Okay, please insert the number of darts that you want to throw. Let me start from 100. I want to throw 100 darts, and the answer is yes, really yeah, this is our answer. This is our real value of pi, and this is the percentage error. So while using only 100 random numbers, we can get value of pi as 4, sometimes 3, sometimes 2, and this is why a statistical or random number cannot give accurate result with very less number of darts. Alright, so let us try furthermore. Yes, while trying with 1000 numbers, let us check the answer. This is the percentage, 2% error. Yes, so error can be reduced by using number of darts thrown. See, somewhere it's 0% error, 0 point something percent error, somewhere 2%, maximum 3%, 4% also. Here in the first value, it is giving 100% error because it is having only 0 as the answer. But while increasing number of darts, the error is decreasing frequently. Alright, this is the calculated value, this is the actual value of pi. Okay, let us further explore more by using 10,000, and yes, now error is very less. You can simply see 3.14 means okay, calculated value is correct to 2 decimal places. Alright, and error is 0.16 in 10,000. Let us try with 1 lakh. 1 lakh number of dots, and the answer is again correct to the 2 decimal places. Alright, so error is very less. Simply you can 10 to the power minus 2 is very small error. So 2 answer is correct to 2 decimal places. And let us give further more number of dots. This is 1000, 10,000, lakh, 10 lakh, and the answer is, okay, it takes certain time to calculate. Yes, again it is correct to 2 decimal places, and error is on the order of 10 to the power minus 2. Let us keep. Okay, so this is how we can calculate the value of pi by using Monte Carlo integration. Alright, so finally 1000, 10,000, lakh, 10 lakh covered. So let us try this. How much error will it give us? Yeah, you can see this is the error, this is the real value of pi, and this is the calculated value of pi. Alright, so it takes certain time to finish this calculation because I have given 10 lakh, so no 1 crore number of darts thrown in the unit circle and in the unit square. So this is how we can calculate the value of pi by using Monte Carlo simulation. Okay, so it's having difficulty in displaying numbers because processor is using its whole total RAM. So yes, this is how we can do that, and with this method, yes, to my best knowledge, I got error as 10 to the power minus 2. Alright, so this is the order of error in my calculation, and you can reduce this error by using further some other methods. Alright, so thank you so much for watching this video, and I would like to thank you all. Please do say something about this work. Actually, I have tried to make this method as simple as possible. Yes, I'm not writing any comments over here. I'm just using very simple numbers, very simple formula without using any tough formulas or tough ways. Please do say something, and I'm sorry for not giving much enough knowledge about random number. Thank you.